Hi, Michelle. How are you doing?
Okay, how are you?
Doing okay. Thank you. We'll start shortly in a minute, I guess. Just some people are still signing on.
I had a family, like it was like an event for new students at a school, so that's why I wasn't there yesterday.
Okay, I understand. That's fine. Hi, everyone. How are you doing? So we are going to do the lab today. I tried to push this up a little earlier, so it went up early this morning. And so the programs that we're going to do today are going to be pretty light. So we're only going to focus on two. And I want to give you a little bit more of like an algorithm based program. So let me get my virtual machine started real quick. So what we have is, 1 second. So this is lab 6 and we're going to do Numba and PyPy. And you can run your program in your IDE if, well, in general, if you use idle or Python IDE, it's fine. It's going to run it as an interpreter. So if you want to run it in Visual Studio, you can also do that as well. It doesn't have to be the Linux virtual machine, but just keep in mind that if you really want to test the program based on time, then you want to make sure that you use something that would have C compiler in the back. So with that said, and then when you run it, you're going to see some differences in time depending on what software you're using. So I put down here that I suggest that you use your virtual machine just to minimize the issue of you installing packages. And then Numba is not going to get linked directly to your system path if you don't tell it. So in that case, we just want to make sure that you have everything set up. Okay. So I recommend it using a virtual machine. And so my Ubuntu is booting up right now. So let's talk about the algorithm that we're going to do today. So instead of doing really simple program, I approached this lab with thinking about how you want to implement something a little bit more advanced but not too advanced where we're going to struggle. So the first part is going to be on a bubble sort. And this gives you a little bit of background on bubble sort if you're not familiar with it. But if you have taken programming classes like C++, CIS5 before, or take some advanced programming class, you probably have heard about sorting program. So bubble sort uses comparison algorithm to really look at two adjacent elements, and it's going to start with the first two. And so I try to highlight that in the tan here. And what it's going to do is going to compare, and whichever the element that's going to be larger, that's going to stay after the element that's going to be smaller. So if you're looking at this example, 14 and 33, it's going to take a look at the first index and the second index in your array or your list. And it's going to use the comparison operator, which is we are going to look for something that's going to be less than. Then if it's less than, then it's going to move it to a temp location. So in the computer, there is no way that we can just swap it directly, like take 14 and put it here, take 33 and put it there. We are going to have to move this to a temp location, right? And then move the other one into its place. So now in the worst case scenario, we know that the bubble sort is going to be 2 to the n squared. Let me fix that. And where we would have the total number of our elements is going to be the n, which is the number of input. Now, when you test your program today, you are going to have it run many times to really get down to the actual time measurement using timeit. Okay, so like I mentioned, bubbles start with the first two elements. The one that's greater is going to be moved to the back, not the back, but the one adjacent to it. And then the one that's smaller is going to be moved to the front. So as 33 is greater, it's going to stay in the same position as it's already in order. And then it's going to move to the next index. So here is index 1 and here is index 2. And then what we are going to do is we are going to compare 33 with 27. Since 27 is smaller than 33, it's going to get moved into a temporary location. And then 33 is going to move into its place, which is from the first index number 1 to index number 2. And then 27 from a temp location is then going to be moved into index number 1. So that's how it's able to sort. It's going to bubble out using a pair of values that's going to be adjacent in index. And then it's going to do that all the way to the end. So if you look at that, the way we loop that is that we want to use comparison operator in our loop. And we want to iterate through all the way until the end of our list or our array. So in a way it is linear, but it is a little bit faster than just checking each individual element against a certain value. So this gives you a little bit of illustration, and then it's going to continue to do that until it gets to the end. And by the time it's done, what you have is you're going to have your sorted list. Okay. And bubble sort is not the fastest algorithm, but it's the easiest one to write for, beginning or intermediate students. So I usually choose this for my programming class because it's easy to visualize. Okay. So we are going to do a bubble sort algorithm. And in the worst case scenario, that it would then go through the entire list. And so the algorithm would be swap every single item in the array. Then you would have the amount of time that it's going to take to do that. So that would take a lot longer than in the case where you have some of the elements that are already in order. So it doesn't have to do the swap. So we know that the time complexity is going to be n squared. So if you do this in your Python interpreter, it is fine. You can still run the program in it. Or if you use Visual Studio, you can also do that. Just keep in mind that we are using some of the library that's using C compiler. So it's best that we want to use something that has C compiler. And if you don't have Visual Studio, you can use the Linux virtual machine. So here I just simply said you can log into your Linux virtual machine. And then we are going to install Numba. So here's my Linux virtual machine. And if you want, you can update it. And if you're using a Raspberry Pi, that's fine, as long as you can install the packages to it. Now, some library might not be compatible with ARM, with ARM, because that's the architecture that's used for Raspberry Pi. So just make sure that you look at the documentation. So here I have my virtual machine. It's Ubuntu. Then I can open this up. Let me see if I can choose a profile that's larger. Okay. And then I will go ahead and put in the installation, and you can refer to the step here. So we want to do Pip3 install Numba. And make sure that if you have my other class, I had my student put the virtual machine on host only. So if you do that, what happens is your VirtualBox setting gets changed. And if you try to connect to the internet, it won't. So make sure that you go into network and then make sure it's on NAT. So that way you can connect to the network. Okay? Because host only is going to prevent you from downloading the packages. So as you can see here, it tells me that number is already been satisfied. Okay. And and it's gonna also put numpy and also, you know, some of the version for numpy and then the number. Then we can make sure, yes, question?
Professor, so well, can you repeat what you said before? So if you get the error, what were you supposed to do?
What kind of error are you getting?
I'm getting error could not install package due to an environment error. Error number 28. No space. Oh, no space left on device.
Yeah, so what you can do is you can use the RM, which is the remove command in Linux. What you can do is you can remove some of the things, like you can remove the desktop. Here, let me find some documentation for you. So you can remove Plasma in Ubuntu CMD. And then if you find this on the search, I think they have yeah, so what you want to use this, I'll copy this and put it in the chat. That's going to free up a lot of space for you, but I keep in mind that it's going to take a while, okay? Because the desktop is is big. Yeah, so Kubuntu, it uses Plasma, and so you can get rid of the Plasma, so it strip it back to this, and then you can free up some space. Okay.
Thank you.
You're welcome. Okay. So once you have the package going, just like before, we can also export our path. Okay. So let me minimize this a little bit. So we can do export path. And then we would say equal home bin path. And we did this last time. So we had gone in and I forgot the $sign here. Then we wanted to put that into bin. And oops. Okay, so we want to export the path and put it into our, I think I have a double, sorry, let's run that again. Okay. So the next command line, the next command on number 4 is going to export the path in Linux. Okay. Now then we are going to write the program. So we understand that Numba uses pure Python. So we don't have to worry about C syntax or any other form of syntax. So you can write your program completely in Python first without putting any library in it first. Okay, except for NumPy. Now, when you look at this program, and I'm going to pull up my Tawny so I can show you the program better, but I try to screenshot it for you. Let's open. So instead of writing two module, which one would be the function and then the second one would be my timeit module. In the last week, what we did was we used the time library and we took a snapshot of the time that the program starts or the function starts and the end time, and we subtract it. So that gives you the amount of, microseconds or milliseconds or nanoseconds, right? Depending on how fast or slow, to be able to see how fast it is. So I wanted to play with the timeit library a little bit, and it took me a little bit of digging, and I had to consult my husband last night on this because it was, the tutorial and the things and the stuff that's provided by the documentation was not clear enough when you are using an argument in your function. Now, having said that, right, even if you globalize your variable, your container, and you integrate the main, because Python does have main. When you call the function on the bottom, it actually enters main, even though it doesn't label it as a main function. So what I did was I had to, since we're using timeit with the main, you have to bring in your container inside the main, like you would declare it. So think about C++ or C. When you have a main function, you usually would initialize your array or your variable there, okay? If you put it at the top for Python, you have to state that it is global object. Otherwise, it's going to get lost when it brings it to main. So what we have to do is that we have to say that when it enters main, it's going to import in a module called timeit. And with timeit, we want to use timeit to measure the time that it takes to call that function and execute that function over so many iterations. So I can run this function 25 times and it's going to give me the amount of time that's going to take to do that. If you change this value to 1,000 times or 100 times, you're going to see that it's going to take longer, of course, because now it has to iterate through so many more times. So as we import in the timeit, we want to print out, right, the value that's going to be returned from the timeit method. And when it uses timeit, I wanted to print out something so you can see how many times it's actually running that loop, right? Because timeit itself incorporate the loop in the algorithm, and it's just going to loop through and it's going to call that function repeatedly, and it's going to measure the time. And I have to put in the import here because main calls this. Main calls the function that I define. And my function uses numpy. So it needs to know that numpy is a module that I'm using with my function. Otherwise, it's gonna not know what to pull from numpy, okay? So then we would declare our array here. And our array is gonna have 1,000 elements. So these arguments means that it's going to start at 0 and it's going to go to 10 and it's going to step through 0.01. So each of the index is going to be 0.01 difference. Okay. And then it's going to fill that in. So we actually have 1,000 elements in that array. Then we are going to create a variable called shuffle. And what shuffle will do for us is it's gonna shuffle the element and then we want to sort it. Okay, so it's gonna randomly shuffle it and then we're gonna we're gonna copy this and then put it into shuffle. Then we're gonna shuffle it. Okay, so this variable, before we apply the shuffle method, we just simply copy the array that we created to it. Then we tell it to shuffle, so it's going to move all the values around. Then we're going to bubble sort it, so that way it's going to arrange it in order for us. And for timeit, we wanted to run it 25 times and measure the time every time it calls the function. And so now in the timeit, you have to use a setup. And in the setup, you are going to import in this file. So what I'm doing is I'm creating a module that's importing its own, okay, itself. So write it as a one file. You can separate it as two modules and then just to import it in. So I would have to have this as a separate file and then be able to import it in. But if you wanted to put it on one file like this is how you do it. In the documentation, there's a very small part on it. And, so we had to dig through and look through some of, the timeit method and how that's used, and then to be able to test it. So we have to break it down into subpart. And now for each of the statement, you have to separate it by a semicolon. Okay, you notice that there. If you don't have that, it's going to throw an error. And each of your statement, you got to put it in quotation marks. Okay, because you're saying that. So what it's going to do is it's going to take each of the statement and it's going to break it down into command, into directives. And then it's going to execute that with this particular method, okay, with timeit. So if I simply run this on the interpreter, you will see, okay, it's going to give me begin 25 times. And so I know that it goes and does it 25 times. And then it's going to tell me that it takes this long, right? And this, again, this is pure Python. So you are going to see slower time. Okay. So then in Linux, let me log in here. So in Linux, when you call up nano, you can write the file. Nano, I think they call it bubble sort. 1 second. Let me double check because I rename it. I think they call it bubble sort new. Oh, I just did it as a PY. Okay. Okay. So I write it directly in here, same as the code that I had provided. Okay. So in the bubble sort itself, let's talk about that. We have a function called bubble sort, and we have n is going to be the length of our array. Okay. We have a nested for loop, therefore you have O of n squared. And we are going to go for the range here. So it's going to evaluate each of the value in the index. And if it's greater, then it's going to move it to the index that's behind. Okay, that's to the right of it. So that's why you do a +1 there. Okay. And then the value that is smaller, it's going to put it into a variable called temp. And we want to do that because there's no magic location. So we have to move it into a temp location. And then And then so when we look to get the new index that's being moved, that's going to be x plus 1. Sorry, it got cut off there, but you can look at the code. And then for the I plus 1, it's then going to put it into the temp. So we basically do a triangular move. You take the value that's large, you put it into the temp, and then you take that value and then you move it to the x plus 1, which is the index that's behind. Then you are going to take the current value that was compared, right, and then move it to the temp, and then move that value into the xi. So ultimately, you'll be able to swap, and sometime you would see that, they would use reassignment for this particular algorithm. And so this is a way that we can actually use the index, and then we can iterate through it after we compare and move. Okay. So when we get here after our loop, we are going to copy our array to the sorted. And then we are going to make it sort, okay, by calling the function. And then I wanted to check to see if all the elements are compared to the original. So that's fine. And then we have the if namespace is equal to main, then we are going to import timeit. And then we are going to print the return value from timeit. And in that, we are going to execute. In main, we're going to call bubble sort. Okay. And the rest that I had already explained. Okay. So then when you're done, you're going to hit Control X to save, and then yes, and then enter. So you have your file. Since I didn't modify anything, so your file would have something like this. Okay, then we are going to execute it as a pure Python file. So you are going to do just like how I did in the interpreter. When you click run, all that is just going to execute it as a Python file. It's going to interpret each line, and then it's going to give you the output. After that, you are going to record the time that it takes to sort 1,000 element, okay, 25 times. And that 25 came from the number value assignment. Then I want to make sure. Okay. Then we are going to run the one with Numba. Okay. So after you run that, you will get an output. Let me see if I can execute it, but let me double check my file. I might have renamed it. Okay. So this, when you modify this with Numba, this is what you need to do. Okay. You need to put the decorator right above the function. So after you run the Python file, you want to modify it. So you would do nano, right? Bubble sort.py. Then you're going to add the decorator. And then you are going to go down. Okay. And you need to import. I'm sorry. Actually, you just put the import statement at the top and it should do it fine. Okay. So there are 2 lines that you need to add at the top for the second round is to put Numba right? So I simply do from Numba import just in time, JIT, and then do a decorator with JIT. And you don't have to do no Python mode here. It's fine doing this. And then you resave the file as bubblesort.py, or in my case, I saved it as a new name. So I can show you the difference. And then when you run it, you would run it with Python again, and it's still use the interpreter, but it's gonna import in this library, and you're gonna see that there's a time difference. Okay. So let's try Python 3, and I'm gonna do the first bubble sort. Sorry, let's do that again. Let me take this out. I'm going to go ahead and remove this. Now let's run it because I think I modified my code. Okay, so we are going to do Python 3. Okay, so as you can see there, and this is pure Python now, right? It's going to go and it's going to give you, and I wanted to put begin there so I know that that's when it's calling the function. And it's going to give me the time once it's done. And if you want, you can have it print out the actual array, but it's just so much on display. So on my virtual machines, it tells me it's 32 point something seconds. Then I can then I would go ahead and go and modify it. Okay, so what I had just done there is this step. Okay, so take a screenshot and then record the time that it runs in pure Python. Then I wanted to import in the Numba library and then put a decorator, save it, and then rerun it again. So let's do that now. So we are going to do nano bubble sort, and we are going to put from Numba, right, import JIT. And then we put a decorator JIT. Okay. And then we are going to press Control X. Let's try that again. I think it didn't. Control X. Okay, save it. Then we're going to run it. See how fast it is? So when you import in the number, right, you would see that it's 30 times in my case, it's 30 times faster. And the factor that you have to weigh in is that it could be, you know, processor and RAM, and then we are running it on the virtual environment. But, you know, if you look at the one before, when you're using it on straight interpreter, it was what, 32 seconds, and then on this one it takes about 1 second that it's able to you know, create those arrays 25 times. Okay, so that was the second part, was to add the decorator and import statement at the top. And then let's say that we wanted to modify this and make it run 100 times and see the difference. for number 10. Okay, so then I'm gonna go back to my file, and then I simply go down to the main. And I'm gonna modify the n value or the number value. I actually had that 125, sorry. So let's say that we wanted to make it 100. We're gonna save it. And then we are gonna run it again. So that time you can see that it's only 0.6 of a second. So definitely a lot quicker. And so let's go back and I'm gonna modify it to make it run 25 times. And so you can see. So if we make it 25 here. So for number 10, all you have to do is to change this. Control X, yes. And then, and so that should be like 0.37 or 0.4. Could be faster in your case. It all depends also on hardware as well. Okay. But if we go higher, like 1,000 times, you're going to see that it's going to take a little longer. Okay. But if we compare pure Python with using Numba, pure Python is slower, but it will run. Okay. So for number 10, after you change it to 100 times, run it, take a screen capture, record the time that it takes to sort compared to 9C. Is there a big difference in time, right? Is it a lot faster or is it very close? Any question?
Professor?
Mm-hmm.
So I had a question on removing the desktop.
Mm-hmm.
So when I tried to do the command, it said unable to locate package KDE.
Okay, so you don't, it didn't have the KDE? That's the one you downloaded, right? The one that I gave you?
Yeah.
Okay. Yeah, it should be. Let me see. Oh, it should be like something like this. You can remove, have you try this? Try that. Let me copy it. Because it could be part of the. Let's put it into the chat. Try that. Because if it's not able to take out the KDE, if there's not complete KDE, it might be able to just take out the plasma. And then you can also try another one after that would be sudo app auto remove.
I think I tried the sudo app. I tried the sudo app remove plasma desktop, and it seems like it took off some stuff.
Okay.
Yeah.
Yeah, it should free up the space there. So.
Okay. All right. Yeah, I think it freed up.
Yeah. All right.
All right. Thank you.
Other questions? Okay, so no questions. All right, let's talk about B, or the second part. This one we are going to use PyPy. Okay, I have a chat question. Can you use Unix time module with Numba? You should be able to, because the timeit was written for Unix time. So if you if you use the Unix time module, that's like the last lab that we did, where you would import in time, but you have to measure the difference in the time that it starts and it ends, because it doesn't have the timeit algorithm. Understand? So you have to write, like, you have to be able to write what that time is. You can say t is equal to, and then the start time for that function when it's called, and then t1 is going to be equal to the end time for that function when it's called. Would you use USR and real? I have not used real, but I can check, right? It might be able to do that. So I think it should be, because it's the same as what they would have in time module for Linux. So you do get a little bit closer. I think if you use real, you might get a little bit closer to real time compared to system time. Okay. For PyPy, in this one, I wanted to do selection sort. This is another algorithm for sort. Selection sort is faster than bubble sort. Selection sort is very much like how when you're dealt a, like a hand of cards, and then you just basically take the large one from the front and then you move it to the back, and then you're going to insert the smaller card into the space that you had swapped it with, or the front. So the algorithm is going to be broken into two parts. You're going to have the sort and the unsort. We are going to move the smallest element of the unsort segment of the list and append it to the sort segment. So it's divided into two sections. Excuse me. Now, we don't have to create a new entire list for the sorted. The way that we would just treat it is that the left side is going to be sorted, the right side is not sorted. Then we are going to search the entire list for the smallest element and then swap it with the first. And the swap mechanism is the same as the bubble sort that we did last, where we would put it into a temp location, and then we would be able to move the element triangularly. So we would know that the first element on the list is going to be the lowest, that it is sorted, it's the smallest, and the remaining element needs to be swapped starting with the second. So as it iterates through, we can implement the for loop or some form of loop until it reaches to the last element. So in a way, it does do the linear as it has to iterate through the rest. But instead of swapping two at a time that's adjacent to each other, like the bubble sort, what you see is the step that's illustrated here. So if I have a 7 that's large in the front and the 2 is the lowest, the 2 is going to get moved to the first position, the index, the first index, because it's going to be the lowest. Then the 7 is going to move to the 2 spot in the back. Okay. Then after that, it's going to take a look at the next value to the 2, which is the 5. And then it's going to compare that, right, with the adjacent, and that's how it's going to swap. So at the end, everything is going to be selected, right, and inserted into the appropriate position from low to high. So then what you have is you're going to have a sorted array. Okay. So as you increase the index, you would need to check for the values that will be less than that particular index. So you would then have to implement for loop in that you would be selecting the value that would be the lower value and put it into the sort side of the array, which is the front. You also have to have an inner loop, and this inner loop is gonna be here, it's gonna iterate to n-1, which is the index, the previous index, and it's gonna be when I is equal to 1. So then for the n-2, when I is equal to 2, and so forth. So in that case, you have to have an inner loop that's gonna be looking at the lower value, and then on the outer loop, we are gonna be able to swap it. Okay, so with that, we also have the time complexity is gonna be n squared. So the program that I have written is here. And so you would start with the function definition. And you would have a for loop on the outside. Your I, the first index on the left is going to be the lowest value. So you want to check against that. And we wanted to iterate through on the inside using another for loop. And we're going to look at the adjacent. We're going to go all the way to the end. So if the value is lower, right, then the lowest index, it's going to be the lowest. So it's going to move that to in front of it. Okay, so swap the value of the lowest unsorted element with the first sorted element. So that's how we're going to be able to compare. So everything in the front is going to be lower on the left side. And then everything else on the right is unsorted. It's going to compare against that. So then what we would have is we would have that the outcome, it's going to store it. It's going to rearrange our entire array. And we're going to have the first index and then all the subsequent index. Now on this one, I didn't want to generate any kind of random value to start. So we are just gonna have the initialized value in the main, which is an inside timeit. So again, we just simply have an import timeit, and then use the timeit method. All I did was I modified this, and then I modified the function call and some of the things that we need to print for that. So this one, we're going to print out the array because it's actually such a small array or a list. So we have 12, 8, 3, 20, and 11. So as you can see, it's not sorted to start. And then we are going to call the method. We're going to call the function. And then we're going to have it sorted. We're going to print it out. And we are going to we are going to test it 25 times. So call it 25 times. And then we're going to print out the time. Okay, so coming back here. Now, the part with this is when you create your program, okay, you need to place it into PyPy folder because PyPy folder is actually in the deeper folder compared to other packages. Otherwise, because it's not linked to your environmental variable path, it's not going to be able to do that. But if you want to modify your path, that's fine. Okay, so let's start with first, we're going to go ahead and download PyPy. Okay, so all you have to do is open up your browser. And then inside your browser, you're just going to search for PyPy download. And okay, so we are going to go PyPy, or you can go to pypy.org. Okay, and then you're going to choose download. Then you're going to scroll down and you're going to choose the download. So I'm going to pick 3.7 because, right, I'm using Python 3, so 3.7 download for Linux because I'm using Linux. But you can definitely use other OSs here, just they're slightly different in the process. Now, when you're prompted this, you have to click save. .7 is the one that we're downloading. So here, make sure you don't open with archive. You're gonna have to save the file, and then we're gonna click OK. So after you had saved it, right, what you're gonna do is you are gonna go into your file manager, and then you are going to go to downloads, and there it is. Okay. You can use this to, you can right click and then you can extract, or what you can do is you can tar it. So I wrote down the instruction here for you that you don't want to open it in archive, but you want to save it. Save it. Okay. And then what you're going to do is you are going to come in here. Okay. And then you can extract it too, or you can open up your command line. And then you're going to run the tar xf pypy dash whatever, but you have to be in the download. Okay. Okay. So if you do extract, you just click this and then you select, and then you would then be able to extract. Any questions?
Professor, how would you extract it again? I'm in the download.
So if once you have the download, you can
Mhm.
right click the file and you can extract. Or if you're using terminal, you just gotta go CD, right? And then move to downloads. And then you would use the tar command.
Oh,
Yeah, but archive should be able to help you extract. See how mine, it would say, you know, archive type is the one.
okay. So, all right.
Go to downloads and then here, right?
Mhm.
And then you're gonna select that, and then you would be able to, you should have be able to right click and then choose extract. So what you would have is this after you extract it, right?
Mhm.
You can extract it there, it's fine.
Oh,
Okay. So once you extract it, let me go back to where I was. So let's say that I was in my home folder. Okay. I was here. And then I go to downloads and I right click the file and then I choose extract. You can extract there if you want, or you can just choose extract to. And then you can browse to your, you know, home student. So I chose to extract to home.
Mhm.
And so I have that there. So just browse to home and you can just put it on home because the rest of your files are under home student. So for the rest of you, right, as you are doing this, when you extract the download packages, put it inside home, and then the directory is gonna be student. Okay, so you can easily find it, but if you extract it to downloads, you can always remove it.
Professor, it says when I tried to extract it to the downloads, it says failed with, it said it failed to create PyPy 3.7 dash.
So right click here, extract to, then on the top, you are going to choose home and then student. Or you can go in and you can use, if that doesn't work, you can use the tar command.
Okay.
Okay. How's that? Is that okay?
Yeah, I'm trying to extract it to the home.
Okay.
Oh,
So
give me an error again.
what does it say?
It says extraction of entry PyPy 3.7-E failed with the error message can't create PyPy 3.7-V7. And it asks me, do you want to continue extraction? And when I say yes, it gives me the same message.
Maybe something's wrong with the file. Okay. You can delete it and then see if you can download it again.
I'll try.
And when you download, just make sure you save it, right?
Okay.
Like here, when you click download, right? So if I click download on this one, it's gonna ask me for this. And if you choose open with archive manager, it's just gonna try to open with archive. You can try that, but I usually just click save. And then you would go into download. See, now I have two, right? And then just, if you have two, you notice that the file name changes. So then you would go back because here, and then you would be able to, you can say open with archive manager, but you can also extract. So let's say if I extract two, and then I can just put it into student, and then select, and it should put it there.
Yeah, download it.
All right. And you can always move it. So you can cut this and then go to home. And then if you go to, student, you can paste it there. Okay. So wherever your PyPy folder is, that's where your code is going to be. That's my point. If you put it in downloads, just make sure that your code is in download. The reason why I put it in home and student is that because a lot of the things that I have used, I wanted to keep it there. So I have it here. So, all right. Now, also because when you're using command line, it's going to default to home and the user account. So in the next step, what we're going to do is we're going to do a pseudo snap. So if you have it in downloads, make sure that you do a CD and then the location of your PyPy folder. Otherwise, it's not going to be able to install snap. So I had downloaded and saved it and extracted to my home and my student folder. And you can always use the file manager to check. So here's my PyPy file. What I'm going to do is I'm going to use Snap here. Okay. And so by default, my terminal is there. So what I'm going to do is I'm going to do a sudo app. And then I'm going to do, I'm sorry, Pseudo Snap install. And you are going to do PyPy3 classic. Because if you try to install regular PyPy, it's going to tell you that for the 3.5 or the 3.7 that you got, that it's only supported with the classic. Okay. So when after you install it with the snap, you will be able to use the PyPy3 command. So with that command, instead of using Python, we can run the program using PyPy3. And PyPy works better with Python compared to the other library that it's actually using the interpreter and be able to convert that to the machine level directives. So it doesn't require a full C compiler in that sense. So therefore it has its own binary packages. Okay. So that's why you have to install it through the snap, and you simply gonna use, because there's two modes to it. There's the PyPy, I forgot what they call it, but the other mode when you install that packages, but for the support of our OS and the version that we're using, you are going to use the classic. Okay. So important, I wanted to put here that you want to open the file manager, open PyPy folder, then open the bin. Click the drop down menu and select and to open the terminal, because this is where you are going to put your program file. So it needs to be in the PyPy directory inside bin. Okay. So what am I talking about? You are going to, and you can use the terminal to do this. It's just, it was late and I didn't want to write the step for it. So here, open up your PyPy folder where it's at. Okay. And then you are going to go to bin. Okay. And then you are going to copy this path. Okay. So all you have to do is go open in terminal, and it's going to open this up. See how it gives me the path already? Then I just write my file. Nano selection 1.py. Okay. Then I just create my file. So as you saw, I have my selection py file here, and that's inside the bin folder inside PyPy3, the extracted folder. And in it, you notice that it has Python 3 shortcut, right? So if you put it there, it's still going to be able to execute it with your PyPy3 command and also your Python command, because PyPy3 uses Python. So whatever you do, make sure that your code is in the bin folder inside PyPy extracted folder. And that's why I put the steps here, is that you would navigate into the file manager. You would go to where your extracted file would be. Okay. And then you open that up. You open up your bin. And then you click the drop down menu here, and then you just say open in terminal. and that opens up another terminal for you, and then you nano. Okay, and then you write your code. Got it? Any questions? Now, if you're good with terminal, you can always, you know, tar it. Once you tar it, you just go in, make sure that it's linked to a certain directory, and then you just cd into bin. Right? The reason why I didn't, I didn't want to get all confused with, you know, where the path is. If you type the path wrong, then, and you can always do the get path for Linux. Okay. So let's do selection sort dot py. Okay. So here's the file. And we talked about our nested for loop. And there's comments for you to refer to. And then we already touched on the main. It looks very close to what we've seen in the last one. But we initialize a list called nums. And then we're going to sort it. We're going to print it. And then we are going to have it run 25 times. Let me see what your snap error looks like. Code 408, get snapcraft.io insertions, snap decorations.
Professor, it worked. Never mind.
Okay. Good. I'm glad it works out because I just tested it today and I was like, they can't be updating it that fast. Okay. All right. So after you write your Python file, then you make sure that you save it inside the bin inside PyPy. So we simply just hit Control X. And then we are going to run it. So we're going to test it in two ways. Okay. After you create your file, the first test that you're going to do is you are going to use PyPy3. Awesome. PyPy3 is going to give you a time that it's going to take to run your program 25 times, right? It's going to sort it 25 times. And the array that the list that we're using is a lot less than what we've seen in the last one. Okay. So when you finish, you simply, but make sure that your syntax here is correct. It's a period slash. That means that you are going to use PyPy3 command, right, for that file. So // PyPy3, okay, and then we are going to use our file or our source code. And I had it printed the array every single time or the list every single time because we had it done 25 times. And it gives me the amount of time that it did to execute the program 25 times. Okay. So you would see that it's a lot less than the last one because our input is a lot less. Okay. Now, if we go in and we change up our number here to 100, and we save it, Okay. Then we're going to run it again. Right? You see the time increase here? Not, I mean, a little more, okay, but not a huge difference there, okay? But you do see that there's time difference as we move, we increase that value. And then you can play with it where you would increase the actual content of the list, right? You can have more indices, you can have more values for it to sort, and you can see how that is going to be different. Then, so once you test it with the 100 times with PyPy, I want you to test it with pure Python and see how much faster or slower it is. Okay. So we did the 25 times and 100 times with PyPy. Now we are going to do the Python 3, just pure Python with it with the 100 times. So here I just use Python 3 and selection sort.py. And I see that it's not a huge difference because remember that PyPy uses Python interpreter. And they even mention in the documentation in the book that sometimes you might see some case scenario that it might be a slower as the output. But depending on the type of algorithm that you have in your functions. But for in general, like a nested for loop like this, it's going to be pretty close. And then if you want to see how it is 25 times, then you nano into it, modify the number to 25 from 100, and then you run it with Python. And so you can compare that to the PyPy. Okay. So that gives you a perspective on how to implement certain library. Now, we are using algorithm that's not very complex, right? We are only iterating through, but in the case where if you're using algorithm for computation more on the advanced level, you have options from Python or CPython to you know, what we talked about today, Numba and this, okay? And keep in mind that PyPy is still at a very earlier stage compared to the other ones. So, but you do see that there's a boost in performance when we implement these type of libraries. Question. Okay. And then when you're done, you can just do shut down now and so on, to make sure that you shut it down all the way, because VirtualBox will not be happy if it's not able to save a state. And then you have to start all over again with making VirtualBox, virtual machine. Okay, so make sure that we answer the questions. Make sure that we we compare the differences. We provided the screen captures. And then, you know, and you can play with it a little bit more. You can extend the content of your list for it to sort for your array and see, okay? Or you can also modify the section where I have it initialized as value. You can have numpy put in and then just have it, you know, put in random values first and then sort it. But keep in mind that you gotta, you know, whatever that you use to initialize the array, you gotta bring that into the main. Otherwise, it's not gonna be happy and it's gonna complain, or it's not gonna work. Yep. And on this one, both of these should be able to run on your interpreter if you have your Python linked to that correctly, right? So in my Tawny, I want to make sure that I install Numba. And then it can't install PyPy directly into here. So, but it would run it as a straight Python file. So with pure Python. And when you look at this compared to what you've seen in Linux, it's definitely slower even on the Python, the pure Python mode. Okay, so when we use it as the object mode, you would see that it's still slower even on the host system side. Any question? And so from here on out, you should be able to do some search algorithm, right? Question?
Professor, so I tried to re-download the PyPy 3.7, but I guess the machine does not have enough space. That's probably why it does not want to.
Okay, so what you can do is you can make sure that you remove some of the stuff that you don't need. Things that we installed in the past. What were the other library? Let's see. We had some C profile ones. You might be able to remove that package. You can probably, let me check. You can probably delete some of the old files that you made in home or whatever. You can just right click and delete and purge it. And then free up. Yeah, I think it's some of these library package, they're big. So, you know, or you can just make another virtual machine and be able to do that. It doesn't take very long. It's like 10 minutes. Okay, so that would be another way. So either way, you're gonna spend about 10 minutes cleaning up or make a virtual machine. That's the inconvenient side of this. Now, you know, let's see. Let me see what other packages. I forgot which packages already. I think we did. You will use Numpy, so don't delete Numpy. We have Numpy, and then you can probably delete like the stuff from week 2, and you can always install it like the C profile one. So to remove, right? You can try to do like sudo apt-get auto remove. And then you can just simply do sudo apt remove and then the package name. Whatever the package that you have, you can remove that as its name.
Oh.
Sound like my problem on my laptop. I constantly have to move stuff around because I have such a small SSD. And whenever I make video, I'm always filling up my C drive, and so I'm always like transferring things out. Yeah, if you want, you can actually let's see. I know that well, no, PyPy, the other one uses. So after you do number 1, you can probably delete Numba, right? And with Numba, it's gonna take also its version of Numpy. So you can do that. I think we had, no, that was just review. Yeah, we did the profilers one. Oh, you can take away that big, that Kcache crying one. That's a big one you can remove. And PyTest. Yeah, you can remove PyTest, and then you can remove Kcache grind. That was in lab 2.
So it would just be sudo
Sudo app remove. Sudo app get remove. I'm sorry. Sudo app get remove. Yeah. And then I think we had, what was it? Let me see which one we install. The build essential for Python. Memory profiler. Yeah, so you can remove memory profiler. And then later on, you can always reinstall it if you need to. Okay. So
Memory. Okay. So I've removed take cache grind and memory profiler so far. Do you think it will give me enough space now? Or?
I hope so. I think so. And then let me see what other things that we added on there. Yeah, so we also install PyProp2 call tree.
Okay.
So you can uninstall that. You can remove that. So that should be enough, I think, for the package.
Okay, let me try to reinstall.
Okay.
Yeah.
Yeah, you can put it, you can install Snap with it, and then it will put the Snap folder so it can execute the command. Okay.
Okay.
All right. Other questions? Let me stop recording.